Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions.
This particular paper is June 2020, paper 1, higher tier.
Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it.
Welcome along to another past paper walkthrough. Now this particular paper's got a bit of an identity crisis. On the front it's written May 2020, but it's part of the June 2020 paper set. And weirdly it's listed on the AQA website as November 2020. But whichever paper set it is, this is paper 1, which is the non-calculated paper. So let's get busy. Question 1. Circle the fraction that is equivalent to 4.75. Okay, well, 4.75, I've got like 2 digits after the decimal places here, aren't they? Tens, hundreds. So I can rewrite this as 475 100ths as a fraction, and then look to cancel down. Now I think 25 goes into both of them, so divide in top and bottom by 25. What's that then? Well, 100 divided by 25 is 4. 25's into 400, well, you get 4 in 100, so you're going to get 16 in 400 and another 3 in 75. So that's 19, isn't it? 19 over 4. It's that one. Question 2. Here is vector A. Circle the column vector that represents A. Okay, well, column vectors are written in the form x, y, and that represents the distance from the starting point of the vector to the end point of the vector. How far you're going in the direction of x, which in this case is 3, and how far you're going in the direction of y. Now that's 2 units, but it's 2 units down, so that's considered to be -2. So this particular vector is going to be 3 where the x goes and -2 where the y goes. So it's that one there. Question 3. Which of these is a square number and a cube number? Circle your answer. Okay, well, I'm going to express these all as powers of 10 first. So 100 is 10 squared. 1,000 is 1 followed by 3 zeros, so it's 10 cubed. 10,000 is 10 to the 4. And a million is 10 to the 6. Okay? Now, squaring is power 2 and cubing is power 3, and 2 times 3 is 6. So, with that in mind, I'm thinking it's going to be this one here. And you can also think of it as like if you've got 10 squared, you could cube that, couldn't you? And that gives you 10 to the 6. Or if you've got 10 cubed, you could square it, and that would give you 10 to the 6. So, yeah, it's going to be a million. Question 4. Circle the reciprocal of 5, 6. Now, a reciprocal of a number is a number that you can multiply your original number by and get 1. So 5, 6 times something equals 1. What is that something? Well, that something is taking a fraction and flipping it upside down. So if I turn the fraction upside down, so the 6 is at the top and the 5 is at the bottom, I could then cancel that 5 with that 5, that's 6 with that 6, leaving me 1, 1, 1, 1, which is 1. Okay, so the reciprocal of 5 over 6 is 6 over 5. Now, don't get confused with the negative reciprocal. When you're finding perpendicular lines and things like that, you use the negative reciprocal, don't you, for finding gradient? This is asking reciprocal, not the negative reciprocal, so it's not negative 6/5. Okay, let's move on. Question 5, use trigonometry to work out the size of angle x. Okay, very straightforward trigonometry question. Okay, first up, let's label the sides. The long side is always opposite the right angle. It's that one there, it's the hypotenuse. This one over here is the opposite, and this one must be the adjacent, isn't it? So I've got the adjacent and I've got the hypotenuse, and I want to find the angle. So, writing down my mnemonic SOHCAHTOA to help me remember which ratio to use, you can see that the ratio involving A and H is this one. It's the cosine, isn't it? So I'm going to write down cos theta equals adjacent over hypotenuse. This is the trigonometric ratio for cosine. And then we're going to sub in the values from our diagram. Theta is the angle, so it's going to be x. So cos x equals, the adjacent is that one there, look, it's 9. 9, and the hypotenuse is that one. It's 18, isn't it? Okay, so it's 9 over 18. Okay, so 9 over 18, that's the same thing as a half, isn't it? Okay, so we've got cos x equals a half. Now, what angle has a cosine of half? Now, we don't have a calculator in this paper, but we do, or we should, have a knowledge of certain angles, our exact trigonometric ratios that we need to learn. I'll just pull up the table of all the values here, and you should see that the angle that has a cosine of a half is cos 60, isn't it? It's 60 degrees. Okay, so that tells me then that x equals 60 degrees. Now, the only way of really doing that is knowing these angles, so you just got to memorize this table. It's not as daunting as it first looks. It's just something you've got to do. Right, let's move on. Question 6, A and B are scatter graphs. What type of correlation is shown by each graph? And we've got a few to pick from. Now, graph A is sloping downwards from left to right, so it is definitely negative correlation. Now, is it strong or weak? Now, those points are very much sitting in a straight line. They're very close to, they're very close to a line of best fit. If I drew one in with a ruler, they're all pretty much sitting on top of it. So that is very strong negative correlation. Strong negative. Now, the second set, pretty much everywhere, aren't they? There's no correlation going on here. Okay, that's it. Question 7. Here is some information about 80 people who play in bands. 12 are singers but not guitar players. 30% are neither a singer nor a guitar player. 1/4 of the guitar players are also singers. Complete this Venn diagram to represent the information. Okay, now it's got this little squiggly symbol here is the symbol for the universal set, and we're told that it contains 80 people. Okay, S is singers and G is guitar players. Okay, so 12 are singers but not guitar players. Let's just go through and do this line by line then. So 12 are singers but not guitar players. What can I do with that? If they are singers but not guitar players, that means they belong in the singers group but not in the guitar group, not in the bit in the middle. Okay. Now it says 30% are neither singer nor guitar players. What's 30% of 80? Well, 10% is going to be, so if 100% is 80, then 10% is going to be 8, and then we can make 30% by multiplying that by 3 then, can't I? So 8, 16 is 24. So there are going to be 24 who are neither a singer nor a guitar player. So this bit of information here tells us that there are 24 sitting outside the two circles. 1/4 of the guitar players are also singers. Okay. Now, we don't know how many guitar players are, but we do know all of the other ranges in the Venn diagram. So I've got 24 who don't play either and 12 who sing only. So that accounts for 36 people altogether so far. That leaves another 44 unaccounted for then, isn't it? Okay, so we're going to have 44 in total in that guitar circle, and I know that of those 44, 1/4 are also singers. So 44 divided by 4, that's going to be 11, isn't it? Okay, so I've got 11 in the middle, and 44 take away 11, 33 in that circle there then. Okay, so that's my completed diagram. Question 8. The shorter side of a parallelogram has length 6.5 centimeters. That's been given on the diagram. The length of the shorter side is 1/9 of the perimeter. Work out the length of the longer side. Okay, so 6.5 is 1/9 of the perimeter, and now we've got another 6.5 on this side, which accounts for another 1/9. Okay, now if 6.5 is 1/9 of the perimeter, then the entire perimeter then is going to be 9 lots of that, isn't it? If I take 1/9 and times it by 9, I'll get 9/9, or the whole perimeter. So if I multiply 6.5 times 9, what's that then? Well, 10 6.5s would be 65, wouldn't it? And then take away 6.5, what's that, 59, 58.5? So the entire perimeter is going to be 58.5. The two perimeters that I know about are 6.5, the two lengths I know about are 6.5 and 6.5, which adds up to 13. So if I take 13 away, so subtract 13, that's going to give me 45.5 to share out between the two other sides. Okay, so then I need to divide 45 by 5 by 2 then, don't I? So 2's into 45.5, what's that then? Okay, so 2 goes into 4 twice, 2 goes into 5 twice, remainder 1. 2's into 15 go 7 times, remainder 1, and 2's into 10 go 5 times. So that's 22.75. So what's the length of the longest side then? It's 22.75 centimeters. Question 9a. All the terms of a geometric progression are positive. The second and fourth terms are shown. Work out the first and third terms. Okay, so a geometric progression is one which has a common ratio. In other words, you get the next term by multiplying the previous term by a number, the same number each time. Now, a good way of writing down geometric progressions that is used quite often is we say that A is the first term, and then the second term you're going to get by taking A and multiplying it through by R, whatever that common ratio is. The third term you're going to multiply through by another R, which gives you AR squared, and then finally you're going to multiply through by another R, it's going to give you AR cubed, and so on. Okay, so I can say then that AR cubed is 16, and I can say that AR is equal to 4. Okay, so what we've got now is a pair of simultaneous equations in A and R. Okay, and what I'm going to do is I'm not going to subtract them, I'm going to divide them. I'm going to divide one by the other. Okay, so what is AR cubed divided by AR? The A is going to cancel with the A. The R is going to cancel with one of those R's there. It's going to leave you with 2, isn't it? Going to end up with R squared. Okay, and that is going to be equal to 16 divided by 4 then, isn't it? 16 divided by 4 is 4. Now that makes R root 4, which is, well, it could be positive 2 or it could be negative 2. Now, it does say that all the terms of the geometric progression are positive, so we're going to exclude the negative solution then as a possibility. Okay, can't be minus 2 because that would not give me a positive other terms. I get positive, negative, positive, negative. Okay, so now I know that r is 2. What does that make a? Well, again, from my two statements up here, my two equations that I made in a and r, I know that ar is equal to 4, and now that I know that r is 2, that means 2a is 4, and that means that a is 2. Okay, so I know that a is 2 and r is 2. So that means my first term is a, which is 2. Then I'm going to multiply it by 2 and get 4, and then I'm going to multiply it by 2 again and going to get 8, and then I'm going to multiply by 2 again and I'm going to get 16. Okay, so my first term 2, my third term 8. Now you could have probably worked that out by inspection, just by looking at the terms and thinking it through, but this method works no matter how difficult the numbers are that they give you. Okay, so it's a good method to know. In part B, we are given the first two terms of an arithmetic progression this time, and we're told that the sum of the first three terms is 90. Work out the value of p. Now the common difference here, what do I have to add on to p to get 5p? I'm adding on 4p here, aren't I? Okay, and then so if I add on another 4p here, 5p add 4p is going to give me 9p. Okay, so the sum of the first three terms then is going to be p plus 5p plus 9p. What's that then? P plus 5p, 6p plus 9p, that's 15p. And we're told that is equal to 90. So if 15p is 90, divide both sides by 15, and it will tell me what p is then, won't it? So p is equal to 15's into 90. Go 15, 30, it goes 6 times, doesn't it? P is 6. Question 10. The cost of a holiday is £2,400. Rana pays a deposit followed by monthly payments in the ratio of deposit to total monthly payments in the ratio of 3 to 5. She makes 6 equal monthly payments. Work out her monthly payment. So let's start by taking our total cost of holiday and dividing it in the ratio of 3 to 5, so we can know how much the deposit was and how much the total of the monthly payment is. Okay, now we can do that by taking the 3 and the 5 from the ratio and adding it together. 3 plus 5, that gives me 8. That tells me how many shares there are altogether. 3 shares for the deposit, 5 shares for the monthly payments, 8 shares altogether. Okay, so we're going to divide 8 into 2,400 to find out what each share is worth. 8's into 2 don't go. 8's into 24 go 3 times. Remainder 0 is going to be 300, isn't it? So 8 goes into 2,400 3 times. 300 times. So each share is worth 300. Okay, so then taking our ratio of 3 to 5 and scaling it up by a factor of 300, that is going to give me 3 times 300 is £900 for the deposit, and 5 lots of 300, that's going to be 1,500 for the monthly payments. Okay, so we've got £1,500 to pay in monthly payments, and we're going to be paying it in 6 equal monthly payments. So now we've got to divide our 1,500 by 6. Okay, so 1,500 divided by 6. So 6 into 1 don't go, 6 into 15, well, that goes twice, and the remainder is 3. 3's into 30 go 5 times, so that's 250 then, isn't it? Okay, so that means that each monthly payment is going to be £250. Question 11. As a decimal, 11/40 is 0.275. Work out what 33 over 400 is as a decimal. Okay, so these are quite closely related, these two fractions, aren't they? So we could take 11 over 44, and now if we multiplied it by 3, okay, what's that going to give me then? That's going to give me 33 over 40. and that's going to be equal to 3 lots of 0.275. So tripling that up, it's going to be what? 600 and 375s, 225. That's going to be 0.825, isn't it? 0.825. Okay. And then, how do I go from 33/40ths to 33/400ths? I can do that by dividing both sides by 10, can't I? So divide by 10, divide by 10. Okay, so 33/400 on the left, dividing that by 10, it's going to be 0.0825, just shifting it 1 unit to the 1 decimal place to the right. Okay, so 33/400ths is going to be 0.0825. Question 12. 2 wire shapes make an earring. The shapes are a circle with radius 21 millimeters and a quarter circle. Now the radius of the circle to the radius of the quarter circle is 7 to 2. Show that the radius of the quarter circle is 6 millimeters. Okay, well the radius of the top one is 21, isn't it? Okay, so if these are in the ratio of 7 to 2, and I change 7 to 21, I'm multiplying through by 3, aren't I? Okay, so if I do the same thing to this side, then that's going to give me 6. Therefore, the radius is 6 millimeters. Okay. Part B says, work out the total length of wire in the earring. Give your answer in the form A pi plus B, where A and B are integers. So this bit here just means leave pi in, don't have to times by 3.14 whatever, which is nice, seeing I don't have a calculator. Right, so let's break this down. So this shape is made up of 2 shapes. It's made up of the circle and the quarter circle. Now the circle is pretty straightforward. The perimeter of the circle is just the circumference of the circle, isn't it? So the circumference of a circle is pi times its diameter, or another way of writing that is 2 pi r, isn't it? Okay, so that's going to be 2 times pi times the radius, which we know is 21 millimeters. Okay, so that's going to be 2 pi times 21, which is 42 lots of pi, isn't it? Okay, so that's all fairly straightforward. Now the perimeter of the quarter circle is not quite so straightforward, because the perimeter is going to be made up of this part here, which is a quarter of a circle, plus these 2 sides, which are 2 radii, aren't they? So that's r, and that's going to be 2 pi r over 4. 2 pi r over 4. So for whatever value of r we've got. Now we worked out here that the radius is 6. So our perimeter is going to be 2 pi r, which is 6, divided by 4 because it's a quarter of a circle, plus 6 for the radius, plus 6, isn't it? So what's that then? 2 pi times 6 is 12, divided by 4 is 3 pi. So that's 3 pi plus 6, which is 12. Okay, so then the total length of wire required, total length, is going to be the circumference of the circle plus the perimeter of the quarter circle, which is going to be 42 pi plus 3 pi plus 12. So 42 pi and 3 pi make 45 pi, and then we've got that 12 left over for the 2 straight sections of the smaller quarter circle. Okay, and now that's in the form A pi plus B, because we've got a multiple of pi plus a number. Okay, so we're good. That's it. Question 13a. S and t are positive integers. X plus s times x minus t is expanded and simplified, and the answer is x squared plus kx minus 40, where k is a positive integer. Work out the smallest possible value of k. Ooh, no, this is all very algebraic, isn't it? Okay, so what do we know here? We know that s times negative t is negative 40. Okay, now what do we know here? Now I think what I'm going to do is I'm going to, I often teach this method for expanding brackets to students who find this difficult. So rather than doing FOIL, that sort of thing, it's just to draw a grid and a bit like a multiplication grid or something. So x and s down this way, and x and minus t like this. That gives it a framework then for working out what all the various terms are. So the first term in this expression is going to be x times x, which is x squared. Then I'm going to have x times s, which is sx. And then I'm going to have x times minus t, which is minus tx. And then I'm going to get s times minus t, and that is minus t s. Well, I should say minus st, shouldn't I, alphabetically? Minus st. Okay? Now, to create our quadratic then, the first term is here. The second term is those two added together. And the third term is this one. Okay? So comparing our grid with what we've been given, I can see that minus st is the same thing as minus 40. So I can just get rid of those negative signs, can't I? So st is 40. And what else do I know? I know that sx minus tx is going to be kx. Okay? Now sx minus tx has got x in common, so I can factorize the x out. I might factorize it to the end, and so it's in the same sort of form. So s minus t x is equal to kx. Cancelling x's. That tells me that s minus t must be equal to k. Okay, so we've got two equations here. I know that s times t is 40, and I know that s minus t is equal to k. Okay, so now I need to work out what is the smallest possible value of k. Okay, well, s times t is 40, so I suppose if I think of all the different factor pairs of 40 that there are, what are the factor pairs of 40? I could have 1 and 40, I could have 2 and 20, I could have, not 3, I could have 4, 4 and 10, 5, yep, 5 and 8, 6, no, 7, no, and I've kind of met myself coming down the other way there, so I know I've got them all. So these are all the factor pairs of 40. So s and t are going to have to be one of these numbers, isn't it? One of these factor pairs. Okay. What we want to do is find the smallest possible value of k. Now we find k by taking one of our factor pairs and subtracting the other one. And the smallest value that's going to be is when these numbers are closest together. So it's not going to be 1 and 40, because 40 take away 1 is 39. That's as far away as possible they can get. So the nearest they can be together is going to be if I use these two, isn't it? Okay, so the smallest possible value of k is going to be where s is 8 and t is 5. So smallest k when s is 8 and t is 5. Okay, so the k then will be s minus t, which is 8 minus 5, k is 3. That's the smallest it can be. Now obviously that's the smallest positive value can be. It's a whole different ball game if it was negative, because you could make minus 39, couldn't you? So that would be the biggest, the smallest possible value if you included negative numbers, but we're not, so it's 3. K is the smallest positive possible value that you can have. Okay, good-o, let's move on. Question 13b, Faisal tries to solve x plus 2 multiplied by x minus 7 is equal to 0. Here is his working. X plus 2 is 0, so x is 2. X minus 7 is 0, so x is 7. Give a reason why his answer is wrong. Well, he's partly right. This bit over here is fine. X minus 7 is 0, so x is 7. That's perfectly correct. It's this bit that's not right, isn't it? If x is 2, then x plus 2 would be 2 plus 2, which is 4, and 4 is not equal to 0. So he's got the sign of that one wrong. So I'm going to say x plus 2 is 0, that means that x equals minus 2, not 2. Okay, that's it. That's all I'm going to say. Question 14a, we're told that c is equal to 2 to the power 10 times 3 times 5 to the power 6. So this is like c expressed as a product of its prime factors, isn't it? Okay, and we need to work out what 18c is, and again given the answer as a product of its prime factors in index form. Okay, so what we're doing is we're going to be taking this expression for c and multiplying it through by 18. Okay, but can we express 18 as a product of its prime factors first? Oh yes, we can. So if we take 18, what can I multiply together to give me 18? I could have 2 and 18, or I could have 6 and 3. Let's go 3 and 6. Okay, doesn't really matter which way around we do it. And then 6 you can multiply together to give you 2 and 3, and 3 and 2 and 3 are all prime then, aren't they? So 18 could be written as 2 times 3 squared. Okay, so 18c could be written as 2 times 3 squared for 18 times by 2 to the power 10 times 3 times 5 to the power of 6. Okay, so kind of collecting like things together. So I've got a 2 there, and I'm timesing it by 2 to the 10 here. So that gives me 2 to the 11. And then I've got 3 squared here and 3, which makes 3 cubed. And I've got 5 to the 6, which is just in the second one. So there we go, 2 to 11, 3 cubed, 5 to the 6. Okay, they're showing it with multipliers in the middle, so let me do the same. Okay, 2 to 11 times 3 to the 3 times 5 to the 6. In question 14b, we've been given what at first glance looks like a fairly horrendous surd and asked to give our answer in as an integer. Okay, but it isn't as complicated as it first looks. Okay, so what I can do is I can cancel that 2 into this power of 2, and it leaves me with 2 to the power of 6. 2 to the 7 divided by 2 is 2 to the power 6. So rewriting it underneath, then the cube root of 2 to the power 6 times 11 cubed. Now I can take that cube root expression, I can break it into 2 separate cube roots multiplied together. The cube root of 2 to the power 6 times the cube root of 11 to the power of 3. Okay, so what is the cube root of 2 to the power 6? Well, the cube root of a number is the same thing as taking the third, or raising it to the power of 1/3. Okay, so 2 to the power 6 raised to the power of 1/3, 6 times a third is just 2, isn't it? So that gives me 2 squared. The cube root of 11 cubed, well, that's just 11. Okay, so I've got 2 squared times 11. 2 squared is 4. 4 times 11, that'd be 44 then, isn't it? Okay, that's my final answer. That's an integer. That's it. Lovely, 44. Question 15. I've got 3x, and that is equal to 1/2 of y. And I need to circle the ratio of x to y. So basically, I've got to take this equation in x and y and change it into a ratio involving x and y. Okay. Now the first thing I'm going to do is going to simplify my ratio up by my equation up by multiplying both sides by 2. What that will do, it will get rid of this annoying fraction here and just leave me with a y. So I've got y is equal to 2 lots of 3x is 6x, isn't it? So 6x is equal to y. Okay. Now imagine people get confused when converting equations into ratios because the numbers seem to jump around in weird ways. But think of it this way, let x equal 1. If you imagine x was 1, what would the value of y be? If we make x 1, then y is going to be 6 lots of 1. So when x is 1, then y is going to be 6 lots of 1, which is 6. Okay? So when x is 1, y is 6. So the ratio of x to y is just 1 to 6. Is that one there? Okay? So even though it's 6x equals y, you kind of naturally gravitate to this answer here, but that is not the right answer. Just think it through. If 6x equals y and x is 1, then y is going to be 6, not the other way around. Okay? Good-o. Let's move on. Question 16. A sequence of numbers is formed by the iterative process un plus 1 is equal to 4 over un minus 1, where u1 is equal to 9. Okay, and we need to work out the values of u2 and u3. Now what we've got here, what this is a term-to-term rule given algebraically, isn't it? Okay, so our second term, our next term in the sequence, we find the next term in the sequence by taking 4 and dividing it by the previous term in the sequence, subtract 1. Okay, so we know, and we've been given, the first term of this sequence is u1, and that is equal to 9. So we know that u1 is 9. Now u2 is going to be 4 divided by u1, which is minus 1, which is 4 over 9 minus 1. 9 minus 1 is 8. 4 divided by 8, that's the same thing as a half, isn't it? It's just going to be a half, or 0.5. Okay, so u2 is a half. u3 we're going to get by taking 4 and dividing it by our previous term, u2, subtract 1, which is 4 divided by a half, subtract 1. Okay, so what's a half subtract 1? A half subtract 1 is minus a half. And what's 4 divided by minus a half? So 4 divided by minus a half, what we can do is we can take that fraction, keep change flip, isn't it? So that's the same thing as 4 times by minus 2 over 1 then, isn't it? Okay, which is negative 8. Okay, so u3 is negative 8, u2 is a half.
Hello from Mr. Tompkins EdTech. Memberships are a feature on YouTube that allows subscribers to directly support creators and to also gain better access to them. As a member of this channel, you pay a small subscription fee and in return receive a range of additional channel perks. Here on Mr. Tompkins EdTech, I provide channel members with their own loyalty badge, which is displayed whenever you comment on any of my videos. I always reply to channel member comments first, and I try to answer all their questions fully. I upload exclusive member-only videos for all you EdTech enthusiasts, and I also post early releases of my popular exam paper walkthroughs. So if you can't find the paper you're looking for yet on my main channel, you'll most certainly find it first in the members only area. As a special acknowledgement and thank you, higher tier members can even have their name appear in the credits of my videos. So if you enjoy my content and you would like to support me make more of it, and at the same time enjoy some exclusive extra perks, then why not sign up today?
Question 17. Jim buys a plant of height 20 centimeters. The graph shows how the height of the plant changes during the next 4 days. Work out a formula for h in terms of n. Okay, so basically we want to find the equation of that line graph there, isn't it? Now normally when we're thinking of equations of straight lines, we use y equals mx plus c, don't we? That's what we're normally using, but we don't have y and x here. Where the x is, we've actually got n, the number of days, and where y is, we've got h, the height of the plant. So what we need to find is a formula h equals mn plus c, okay? Where m is the gradient and c is the y-intercept, just like we normally do with equations of straight lines. Now, where is c? Where can we find c? C is where the line crosses the axes, which is here at 20, isn't it? So c is going to be 20. So we now need to find what the gradient is there to write in front of n. That's the last thing we need to do. Okay, now to find a gradient of a straight line, what you do is you take 2 points on that line. We're just going to take the end points, and I'm going to form a little triangle between them. And I'm going to see if I can work out what the change in y is and the change in x between those 2 points. Okay, now the height of that triangle, it goes from 20 up to 32. So that's got a height of 12 and it's got a length of 4, isn't it? Okay, so the gradient of this line is going to be gradient m is equal to change in y, 12, divided by change in x, 4, and that's 3. Okay, so the m in my equation is going to be 3 then, isn't it? Okay, so we're going to write that 3 in there. So the equation that, or the formula that links h to n here is h equals 3n plus 20. Okay. Question 18. Solve the simultaneous equations 2x plus 4y equals minus 9 and 2y equals 4x minus 7. Okay. Now these are just linear equations in x and y, so probably the easiest way of solving them simultaneously is by elimination. But they're not written in a way that makes elimination so straightforward. It's nice to have them something x plus something y equals something, and then we can subtract or add one from the other to simplify. So I'm just going to rearrange them first. Okay, so let's take these and rearrange. I think the first one's all right. 2x plus 4y is equal to minus 9. That's already in the form we normally do for elimination, but the other one is not matching, is it? If I subtract minus 4x from both sides, I'm going to get minus 4x plus 2y is equal to minus 7. Now, in order to eliminate one of the variables, I need to have the same coefficient for both. So I'm going to take this second equation, I'm going to double it up. I'm going to leave the first one as it is. So I've already got 2x plus 4y is equal to minus 9. Doubling up the second one, I'm going to get minus 8x plus 4y is equal to minus 14. And then to eliminate y, I can subtract 1 from the other then, can't I? Okay, so if I subtract the second equation for the first one, my 4y's are going to cancel. Okay, now what happens with the other things? I've got 2x take away negative 8x. Now, taking away a negative is the same as adding. So 2x take away negative 8x is going to give me 10x. And negative 9 take away a negative 14. Again, two negatives kind of make a positive, don't they? So negative 9 plus 14, that's going to give me 5. Okay, so 10x is 5. Dividing both sides by 10 gives me x is equal to 5 over 10, or 1/2. So x is a half. Okay. Now once I've got x, all I need to do now is to sub back into one of my original equations and find y. I'm going to, let's take the second one. 2y equals 4x minus 7. So 2y equals 4 lots of x, which is a half, minus 7. 4 times half is 2. 2 take away 7 is minus 5. So 2y is minus 5. So y then is going to be minus 5 over 2. Okay, it's minus 2.5. I'm just going to leave it as minus 5 over 2. Okay, so my solutions are x equals a half, y equals minus 5 over 2. Okay, done. Now we could just double check by subbing it into one of the other ones, but it's going to be fairly horrendous. So you can try that if you like. Question 19. Circle the expression that is equivalent to x over 5 plus x over 10. Okay, now when you're adding fractions together, you need the same denominator, don't you? So I can do that by timesing top and bottom of this first fraction by 2. So that's the same thing as 2x over 10 plus x over 10. So then I just add the numerators, don't I? It's 3x over 10. So it is that one there. Question 20, part A. Write down the value of 7 to the power 0. Well, anything to the power of 0 is 1. So that's 1. B. Work out the value of 32 to the power of minus 3 over 5. Okay, now with these complex indices, you can break them down into 3 separate steps. Okay, I'm going to deal with the minus sign first. Then I'm going to deal with the fractional denominator, and then finally I'm going to deal with the fractional numerator. So 3 separate steps. Okay, so 32 to the minus 3 over 5. So dealing with the minus sign first, a negative index means the reciprocal, or 1 over the positive version of that index. So that's the same thing as 1 over 32 to the power of 3/5. So the minus sign is gone because I've kind of applied it, haven't I? Okay, so that's disappeared. Now so that's the first part done. Second part, let's deal with the 5. Now a fractional index is the same thing as that root of the number. So a fifth is the 5th root. So I want the 5th root of 32 and then raised to the power of 3. That's another way of writing it. Okay, so I still need to do with the cube. I'll deal with that last. I'm going to do the denominator first and find the 5th root of 32. Now, I'm pretty sure it's 2 because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the 5th root of 32 is going to be 2. So that's a half, or 1 over 2 to the power of 3. Okay, so I've dealt with the negative sign, I've dealt with the denominator, just need to deal with the numerator now. 2 to the power of 3 is 8, so my final answer is 1 over 8. Question 21, write these numbers in order of size. 15.6, 3 lots of the root of 23, 2.1 to the power of 4, and 47 over 3. Now, a lot of these are fairly horrendous to do without a calculator. I am not going to do those. I'm going to just estimate them because I think they're going to be far enough away from each other that I can estimate the size of them and rank them that way. Okay, so 15.6 is already as a decimal. I'm going to try and convert them all into a kind of a decimalish number. Okay, let's have a look at this first one we need to evaluate, which is 3 lots of root 23. Now, I am not a computer. I do not know what the root of 23 is, but I know the root of 25 is 5. And I know the root of 16 is 4, and I know that 23 is between 16 and 25, and actually it's closer to 25 than it is to 16. So I'm thinking that the root of 23 must be 4 point something, close to 5, so like 4.8, 4.9, something like that. So let's say it's about 4.8, a little bit under 5. If I multiply that by 3, I'm going to get something that is a little bit less than 15, aren't I? It's definitely less than 15, okay? So I know that this one here then is going to go before the 15.6, and it has to be before that one because this one is definitely below 15, whereas that one is definitely above 15, okay? Let's take a look at the power 4. Now, powers get very big very quickly. Now 2.1 to the power 4. I know that 2 to the power 4, what's that? 2, 4, 8, 16. Okay, so 2 to the power of 4 is 16. So 2.1 to the power of 4 is going to be greater than 16, isn't it? Now I don't know what it is yet, but I know it's probably going to be like 17, something like that. So I know it's going to be to the right of 15.6. Okay, so I'm going to leave where it is for now. And then 47 over 3, what's that then? Well, 45 over 3 would be 15, isn't it? So if I break this into 45 over 3, which is 15, and then I've got 2/3 left, haven't I? So it's 15 and 2/3 basically. So 2/3, what's 2/3? 2/3 is 0.66666666. So that is going to kind of go in between then the 15.6. It's bigger than 15.6, but it's smaller than 16, isn't it? Okay, so it kind of slots between these, okay? So ranking those then, this is going to be the smallest one because it's less than 15. Then we're going to have this one because it's 15.6. Then we're going to have this one because it's between 15.6 and 16. And then we're going to have this one, which is more than 16. Okay? I'm not going to work them all out. It's only a 2-mark question. Just need to rank them. Okay, so what is the rank? Let's start with 3 root 23, then 15.6. Then 47 over 3, and finally 2.1 to the power of 4. Okay, from smallest to biggest. Question 22a. Y is directly proportional to the cube of x. Y is 17 when x is 4. Work out an equation connecting y and x. Fairly straightforward proportionality question. Now first off, this bit here tells me the relationship between the two things, y and x. So I can tell from this that y is proportional to x cubed. Now I can replace that little fishy symbol with equals k lots of x cubed, where k is the constant of proportionality that I can then go on and find. Okay? Now, they always give you a pair of values that go together, and these pair of values that go together are specifically for you to find that constant of proportionality. So that's what we're going to use next. We're going to say when y is 17, x is 4. So subbing those in, then 17 is going to be k lots of 4 cubed. Okay, what's 4 cubed? 4, 16, 64, isn't it? So that's going to be 17 equals 64k, which makes k equal to 17 over 64. Okay, so once we know the constant of proportionality, we can take this 17 over 64 and write it here in our equation, and then we'll have the complete equation linking y and x. So then y is equal to 17x cubed over 64. That is the equation. Okay, job done. Part B says m is inversely proportional to the root of r. The value of r is multiplied by 4. Circle what happens to the value of m. Right, so m is proportional to the inversely proportional to the root of r. Okay, in other words, m equals some constant over root r. Okay, now I don't know what r is, but if I should times it by 4, so it gets 4 times bigger, what's going to happen to m? Well, if I replaced r with 4r, so instead if I had m equals k over root of 4r, then what does that do to m? I suppose what it does to m, if I take 4 out of that root, that is the same thing as k over 2 root r. Now once I've done that, you can see that this was the original thing that m was. So now I've got like half of k over root r. Okay, in other words, I'm going to be dividing m by 2. Okay, question 23. ABCD is a quadrilateral. Prove that ABCD is not a cyclic quadrilateral. Okay, so a cyclic quadrilateral is a special sort of quadrilateral. You would normally see it drawn inside a circle, but if I take the circle away, it's still a cyclic quadrilateral. It's not the circle that makes it a cyclic quadrilateral. It's the fact that the angles in the cyclic quadrilateral, the opposite ones add up to 180 degrees, don't they? So that one and that one together make 180, and the other two make 180. Okay, so in order to show that this is not a cyclic quadrilateral, we're going to have to find all the angles and show that the opposite ones do not make 180 degrees. Okay, now one angle is given as a number down here, it's 92, but the other 3 are given algebraically. Okay, now we know that the sum of the interior angles of a quadrilateral add up to 360 degrees. Well, you should know that. A quadrilateral is made up of 2 triangles, each triangle 180, 2 180s, 360. So if I take the 4 angles and add them together, it should give me 360 degrees, and in which case I can then work out what the x's are then. Okay, so I'm going to use the fact that my 4 angles, 4x plus x plus 36 plus 5x plus 30 plus 92 equals 360. Okay, they all add up to 360. Okay, so let's just collect like terms. I've got a 4x, an x, a 5x, and that's it. And then I've got a 36, a 30, and a 92 that I need to add up. So 4x, x and 5x, that's going to give me 10x. 36 and 30 and 92, what's that? 66, 156, 158 plus 158, and that is equal to 360 degrees. Taking 158 away from both sides, what's that give me? So it's going to be 10x on this side. 360 minus 158, that is going to be 202, isn't it? And so x then is 20.2, I suppose, degrees, 20.2. Okay, so given that x is 20.2, then 4x is going to be 4 lots of that. That's going to be 80.8 then, isn't it? Okay, so this one up here is 80.8. Okay, so can I add 80.8 to 92 and make 180? No, I cannot. And that is why this is not a cyclic quadrilateral. I can say if cyclic, then angle A plus angle C equals 180. But what I have got is 80.8 plus 92, that's 172.8 then, isn't it? Which is not equal to 180, therefore not cyclic. I think some of my work here might have pooped off the edge of the screen there. Let me just kind of shift it over a little bit so you can read it. Question 24. Y is an obtuse angle. Which statement is true? Tick one box. Sine y greater than 0, cos y greater than 0, etc., etc. Okay, so to work out which box I'm going to do, I'm just going to quickly sketch sine x and cos x to remind myself what they look like. Okay, so if I was going to draw sine x, it's just the sine curve starts at 0, doesn't it? It goes up and then down and then back up to 0 again. Okay, and it does that in 360 degrees, one cycle. So that's 180, and that up there is 90. Okay, now obtuse angles, where are obtuse angles? They occur between 90 and 180. So the values of x we're talking about are between there and there. I can see that the sine curve is positive for that period of time. Okay, so it's definitely sine is positive, so it's not going to be that one and it's not going to be that one. Now what's cos doing? Now cos, let's just switch pen. So cos starts at 1 and then it heads down to 0 at 90, and then it is at minus 1 at 180, and let's just put 270 in there as well, and then it's back up to 0 at 270, and then back up to 1 at 360. Okay, so then again the period we're interested in is from 90 down to 180. You can see from that they are kind of negative down there, aren't they? So sine is going to be positive and cos is going to be a negative. So this one here, so that is the box I'm ticking.
Advertisement break. Looking for a maths tutor to help you through your GCSE, A-level or IB exams? Then why not check out Mr. Tompkins Tutors at mr.tompkins.online/tutors. Mr. Tompkins Tutors offers personalised one-to-one quality tuition online via Teams direct to your home. Tuition is delivered by myself and a team of first-rate teachers who I've personally known and worked with for years. All have qualified teacher status in the UK and a recent full DBS disclosure, so you can be confident that you're in good hands. To find out more and request a trial lesson, simply visit the website linked below and complete the online form, and we'll be in touch with you soon. Until then, let's get back to the maths.
Question 25. A histogram is drawn to represent the heights of a sample of women. 3 of the 4 bars are shown. The bar from 170 to 180 is missing. There are 74 women in the sample. Complete the histogram. Okay, So I think what we need to do is work out how many are in the other 3 bars and see what's left over for our final 170 to 180 bar. Okay. Now with a histogram, which is what this is, we have a frequency density on the y-axis and not frequency. So the heights of these are not the number of people, it's the area of each bar that is going to give you the number of women that are of that height. Okay. Now you can get frequency back by multiplying the 2 sides of your rectangle together. Okay, so it's the area of the bar, isn't it? So this one here, the 150 to 155, you can see from 150 to 155, that has got a width of 5 units that way. And the height then is 2 from the frequency density scale. So then the number of people, the frequency in here is going to be 2 times 5, isn't it? And that's going to be equal to 10. So there are 10 women in that first box, that first rectangle. Now the second rectangle has got a width from 55 to 65, that's a width of 10, and it's got a height of 3, so its area is going to be 3 times 10. That tells me that there are 30 women in that range. And then finally I've got a bar which has got a width of 5 and a height this time of 4, so the area of this bar is going to be 4 times 5. That gives me 20. Okay, so you can see we've got 10 plus 30 plus 20, that's 60 women accounted for already. Now we were told that there are 74 women in this bar chart, or in this histogram, so then the final bar is going to represent 74 minus the 60 women we've already assigned, so it's going to represent 14 women. Okay, I'll just write that 4 probably. 14 women, and then the bar goes from 170 to 180, so the class width is 180 minus 170 is 10. So the frequency density that we need is going to be frequency divided by class width, which is 14 women divided by a class width of 10. So we need to do our bar of a height 1.4. Okay, so using our ruler, I'm going to find 1.4 on my scale here. Now between 1 and 2 I've got 5 little divisions, so each one of those little divisions has got to be 0.2, isn't it? 1, 1.2, 1.4, 1.6, 1.82. So we're talking 2 little squares up from 1, aren't we? Okay, so 2 little squares up from 1, across from 170 all the way over to 180. Just change direction, go down, oops. Okay, and that represents my 14 women then. Okay, all done. Show that 14 over root 7 can be written in the form a root b, where a and b are integers. Okay. Now mathematicians don't like to have irrational denominators like this. Can you can probably imagine like a pizza divided up into 7 pieces, but can you imagine a pizza divided up into root 7 pieces? I can't. So you can see why mathematicians kind of don't like them very much. So luckily there's an easy way of converting between them. What you do is, if you've got an irrational denominator like this, just times top and bottom by that same value you've got on the denominator. Root 7 divided by root 7 is just 1, so all I'm doing is multiplying through by 1, so I'm not going to change the value, but I will change its form, because root 7 times root 7 is 7, and that leaves me with 14 root 7 on the top there. But you'll probably see that my 7 down there cancels into my 14, and that leaves me with 2 root 7, and that is my answer in the form of a root b then, isn't it? A is 2, b is 7. Okay, so 2 root 7. I don't have to write a and b, I just need to have it in that form, so that's all fine. Okay, let's move on. 26b, work out 2 root 10 times root 80 times root 18. Give your answer as an integer. Now obviously I don't have a calculator for this. I'm just gonna, I'm gonna try some things out. Don't really know the best way to do this. I think what I'm going to do is I'm just going to put them all under one root. So I've got like 10 times 80 times 18. I'm going to see if I can find like ways of rewriting these numbers in terms of their factors, and see if I can pair up the factors to make squares. What I mean by that is like 10 is 2 times 5, isn't it? So I could rewrite 10 as 2 times 5, and I could rewrite 80 as 2 times 5 times 2 times 5 is 10 times 8 then, couldn't I? And then I can write 18 as 2 times 9. Okay, so my plan is to try and pair things up. Okay, so I've already got one pair. I've got a few pairs going on already, haven't I? I've got like 2 and 2, and I've got 5 and 5. I haven't got any more pairs than that yet, but we haven't finished yet, have we? Let's keep going. So 8, what could that be? That could be 2 times 2 times 2, and that's times 2 times 9 then. So I've got a few more pairs here, haven't I? I've got another pair of 2s, and I've got another pair of 2s, and that 9 actually I can rewrite as 3 times 3. Okay, so do you get what I'm doing? I don't. Oh, I kind of do. So let's just put that all. I haven't really written it properly yet, have I? So that's that. That's equal to that. That's equal to that. So this is equal to 2 times 5 times 2 times 5 times 2 times 2 times 2 times 2 times 3 times 3. Okay. Now the reason I'm doing all that is because I then want to pair these up into squares, and then I can square root my squares and just leave normal numbers. Does that kind of make sense? So my yellow ones then, that is going to be 2 squared. My 2 green 5s, that's 5 squared. And then I've got 2 squared and 2 squared and 3 squared, all square rooted. Okay, so then that I can square root all my squares, and that's going to leave me as 2 times 2 times 5 times 2 times 2 times 3. Whew. Okay, it's a lot to multiply, but we can do it. So 2 times 2 is 4, times 5 is 20, times 2 is 40, times 2 is 80, times 3 is 240. Done. Okay. Well, I didn't really know what I was doing there, but it kind of came together at the end. Cool. 240. Question 27. A and B are similar solid cylinders. The base of area A to the base of area B is in a ratio of 9 to 25. Complete these ratios. Curved surface area of A to the curved surface area of B, and the height of A and height of B. Right, so we've got 2 cylinders. They are similar. So cylinder A, cylinder B, which is a bit bigger. Now let's have a look at the base area. I've kind of drawn the base underexposed, and so I'm going to use the top, which should be the same as the bottom, but you get the idea. So these are in the ratio of 9 to 25. Now these are areas, these are 2-dimensional shapes. Okay, so if I want to know what the ratio of their heights are compared to these, I need to square root them. Okay, so I mean if 2 shapes are similar, then their lengths are going to be in the ratio of x to y. The areas are going to be in the ratio of x squared to y squared, and their volumes are going to be in the ratio of x cubed to y cubed. So we've kind of been given the base areas, which is this one. So I want to go back to lengths, don't I? For the heights, don't I? Because height is a length. So if I want this one, then I need to square root my area formulas, my area ratio, to get the length one. Okay, so if areas is 9 to 25, then the length one is going to be root of that. It's going to be 3 to 5. Okay, volumes would be the cube of that, so 27 to 125, but we don't need that one. Right, the curved surface area of A, they're all going to be in the same ratio. They're going to be all areas are going to be 9 to 25, and all lengths are going to be in the ratio of 3 to 5. Okay. Question 28. Factorize fully 144 minus 4x squared. Okay. Now, this is a difference of two squares, isn't it? 144 is a square, 4x squared is a square. So it's going to factorize as all difference of two squares do. A squared minus b squared factorize into a plus b, a minus b. That's what it's going to look like. So it's going to go into two brackets. Okay. Now what we need to work out is what's the square root of each of those things. So the square root of 144 is 12. So I'm going to have 12 and 12 here. And I'm going to have plus and minus. And the square root of 4x squared, that's going to be 2x, isn't it? So it's 12 plus 2x, 12 minus 2x. And that's it. We factorized it fully. 2 marks. Good job. Let's move on. Question 29. The graph of y equals x cubed plus 6 is translated 4 units to the right. The translated graph has equation y equals f of x. Work out f of x. Give your answer in the form x cubed plus ax squared plus bx plus c. Okay. Don't really need a sketch, but I'm just kind of visualizing the problem. X cubed plus 6. So it's going to be a graph that looks like that, and I'm moving it a little bit to the right. So my new graph is going to look like that. So this is translated like 4 units to the right, isn't it? Okay. So it's a translation of 4 units in the x direction. Now you need to know about how of 6 different types of transformations for the GCSE exams. You need to know reflection, stretches, and translations. Okay, I'm going to pull them all up here so you can have a quick look. Now we are translating 4 units to the right, so that means y equals f of x is going to go to y equals f of x minus 4. Okay, now when you sub inside the bracket, it's kind of the signs kind of switch around. It's just kind of what happens. So translation of 4 units to the right, now that is y equals f of x minus 4. Now given that our function here, f of x, is x cubed plus 6, what we are wanting to find is f of x minus 4. So replacing x in this equation with x minus 4, I'm going to get that, aren't I? Okay, but what is x minus 4 cubed? So writing that as 3 brackets. We're going to do lots of FOIL here. So, well, I'm probably not, because I'm just going to use an identity for the first one. I know that a plus b squared is a squared plus 2ab plus b squared. So I'm going to use that to quickly expand the first bracket. So first 2 pairs of brackets, sorry. So that's going to be x squared minus 8x plus 16. Okay. Times by x minus 4 plus 6. Okay. Now we're going to do some more multiplying. I'm going to multiply everything by x, and then I'm going to multiply everything by minus 4. So multiplying everything by x first, I'm going to get x cubed minus 8x squared plus 16x. Okay? And then multiplying everything by minus 4, I'm going to get minus 4x squared. Negative 4 times negative 8x is positive 8, 16, 32, isn't it? 32x. And then minus 4 times 16 minus 32 minus 64, isn't it? Okay. And then I've got plus 6 on the end. Okay. So, collecting like terms, I've got x cubed minus 8x squared minus 4x squared is minus 12x squared. 16x and 32x is 48x. Minus 64 plus 6 is minus 58. So then that is my new equation then. Y is equal to x cubed minus 12x squared plus 48x minus 58.
You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.